welcome to the first talk this afternoon. And I will try to provide you with an answer if your next API will be event-driven or not. But to start off the talk, let me first introduce myself. I'm Joost Heldens. I'm a seasoned integration architect, and I'm currently working at Archers. Seasoned, as you see with my receding hairline. I've been around a couple of years, and throughout my career, I've been working in the telco industry, and furthermore, then I moved on to banking and health insurance, and then my last engagement was in the retail sector. As I said, I've been working now for Archers. Archers is part of the Kronos Group, and within the Kronos Group, we are part of the CBX family, and this family encompasses a couple of competence centers, and so I'm part of Archers, which is a competence center that focuses on integration, architecture, and analysis. So what do? Yeah, we go different aspects of the integration problem space that goes over API management, the introduction of API management solutions, over to, of course, event-driven architectures as well, but also applied observability. So how can you monitor your system, what are the solutions there, and how you can best implement that. And finally, yeah, of course, we also help organizations determine their integration strategy and then plot out a roadmap to implement those. So that's a little bit about myself. But let's start with trying to answer the question, will your next API be event-driven? And in order to do that, we need to understand what is event-driven, what it promises, and what are the promises that this new way of working with APIs, what does it promise? And in order to understand that, this promise, we need to look at in which context these promises are made. Yeah? Once we understand the promises and we know in which context these promises are made, we can determine then what does it really mean for us. When we try to build a solution, how does it apply? And then once we understand the meaning, we can see, okay, now we understand the entire problem space, but how does it apply to the real world? Can you apply it? Is it ready? And so that finally that brings us hopefully to the fifth point that will then answer this question, will your next API be event-driven? So let's start off with the first thing, with the promise. And so what I did is I looked through the internet and, okay. So there's a delay here. So I looked through the internet and looked up some different quotes there, and what you see there is that it promises to be better, faster, better time to market. So there's a lot of things there that says that if you summarize it, that these events is actually the next evolutionary step. Like I said, they are faster, they promise you to be better, to be more robust, and even have a faster time to market. Summarized, events are really the holy grail and they can do everything. But in order now to understand these promises, like I said, you have to understand in which context these are made. And so if you look at this context, you always see that they make a distinction between events versus APIs. And so that brings us to the next step. What do we understand by APIs? Because APIs, really, it's a term that means a lot of things to different people. And for this talk, and that's also when you look through the documentation, I want to bring back the definition of an API to what we consider REST-based APIs. So when you look at these events, most of the time they're compared to APIs, REST-based APIs. And then if you look at those REST-based APIs, we all know they are facing some challenges when we try to implement those REST-based APIs. So let's first see how these work. Yeah? So you have a consumer you post a request, and the API processes it and sends back a response. So you have there a request being, give me a list of orders, the API processes it, and it comes back with a response. So that's one way of implementing that. And the other way, a little bit less known, but also that you can see is when you just ask something and you really don't require a response back. There will, because the protocol requires it, there will be a feedback that says, okay, I've done it, but basically that's what it is. So as I said, they pose some challenges. The first one being reliability. Like when I mentioned on the previous slides, what you see there is that when you do this call to the one to one of your API providers, if that provider is not there, your API will not finish. Your API call will not finish, and you will not be able to provide the functionality that you intended to do. So your solution, basically, because more normally, if you build a solution, you do a lot of API calls, is only as robust as your weakness. That's the first thing. The second one has to do with performance. In an API solution, what you do is you rarely only call one API. Most of the times, that API in turn will call another one, and what you see, you have certain API chains. So in order to do something, you basically call a first API, that one calls a second one, that calls a third one, and you have this change, which means that even though each of these API calls are fast, and if you look at the entire chain, you introduce latencies, which can have a negative impact on your performance. The third one is push versus pull. APIs have a pull mechanism, meaning that in order to get information, you have to ask for it. And sometimes you don't know when you do the call if that information will be available or not. So what you will start doing is you will start polling. You will see, give me all the orders. The orders are not there. I wait a couple of seconds and then I will start doing the next call again until I get my information. Meaning that even though the information is not there, you constantly sending information over the line. Not only that, but you're also consuming needless CPU resources, because every time that your API provider sees is there information, no, and sends back there is no information. So you have there a certain inefficiency into the system. The fourth one being the processing of high volumes. Typically with APIs, you can send a lot of information over the wire, but like I said, if you have a list of orders, if you then return 10,000 orders there, getting that data over the wire is not efficiently. And sometimes you can go around that with streaming, so there are solutions for it, but they're not easy. You can implement paging, sometimes that doesn't work very well because you have it's not really relevant to your use case. On the other hand, once you've got that data, you have those $10,000. Now, what are you going to do with it? Are you going to dump it into your database? Are you going to dump it into your file? If you do it in file-based, what about then virus protection and all that kind of stuff? So there's some clunkiness there as well. And then finally, there's a problem of visibility. Because the client and the provider needs to communicate one another, of course, they need to know about one another. And so we have solutions there that have a direct use service where you can do certain lookups, where you can find your endpoint, but basically you need to know who you're talking to. So if that service goes down, if you don't know it yet, then you no longer can talk to one another. So you have this visibility where everybody that needs to talk to one another needs to know each other. So these are the challenges that we have when looking at those traditional APIs. But we all, I think all of us in the room, we all know about these challenges. And in the meantime, we tried to avoid those because we are aware of them. And most of those challenges are related to the way that the communication is done with those APIs. it's most of the time it's synchronous communication that we set up. But we know this problem, and we try to figure out ways around these shortcomings, I would say. So what we did is we tried to introduce an asynchronous communication. Meaning, what does it mean, an asynchronous communication? An asynchronous communication is a communication where you pose a question to your provider, but that provider will not directly give you an answer back. You pose the question, that provider will process it, and once it has the answer, it will call you back. And basically, that's I put it here. Don't call us, we'll call you. Basically, if you want to make an appointment with somebody, you pick up the phone and you talk to the receptionist and says, "Yeah, I will see if there is room in person's X's agenda." And once she finds a room, she calls you back and says, "You have an appointment at 3 o'clock." So that's basically the way of this asynchronous communication. And there are different ways that we can implement that. One of them, traditionally with APIs, is what we call callbacks or webhooks, where you have a client. Again, it wants, let's say, it wants to have a list of orders, or wants to create an order here. So what will happen? The client will send a message to get the information across. The service accepts it, but will not directly process it. So there will be a time delay. It will just say, "Okay, I've received your request, and I'm not going to do anything right away with it." And then at its own leisure, it will process it, and it will create a request. And once it's processed it and it has finished it, it will send that response back. And so at that point in time, the client will receive that. And that's why we call it a callback, because it will call the client back and says, here's the answer to the request that you post. So that's one way to implement this asynchronicity within traditional API calls. Another way how you can do it is using a command pattern and with the introduction of a broker. A broker being an intermediate, you can kind of compare the post office system that sits in the middle. And there, the communication is similar, but basically what you do here is the client sends, and that's why it's called a command pattern. It's called a command message, where it instructs something to do, and it sends it to the broker and says, I want to create an order. The broker then says, "Okay, I've got here this command message, and I know I need to create an order." And it says, "Okay, this service is there. Its responsibility is for creating those orders, and you can send it to that service. Service receives that message from the broker. Again, it will do processing, and once it has finished, it will send the result back to the broker saying, "Yeah, you asked me to do something here to create an order. I've created that order," and then it's up to the broker to provide that answer back to the client. Again, a way of introducing this asynchronicity through this pattern. Meaning, there are certain things, certain problems that you can solve with introducing not a synchronous communication, but an asynchronous communication. So, what are these advantages? The advantages are, so if you look at the last example, your solution becomes more loosely coupled by introducing the notion of this broker in the middle. The client and the provider no longer need to know each other directly. They each need to know the broker, but they don't need to know each other directly. So you kind of try to solve this visibility problem. On the other hand, also on the performance point of view, you also introduce buffering, meaning that since you as a client no longer expect directly a response back, the service provider, he can at his leisure try to come up with the answer that you are asking for, but it's inherent at the protocol. And that's basic. That is the third benefit of this thing is that it makes your communication, your asynchronous communication, that you're dependent on another party explicit. Because with this protocol, what you say is you send something and you know you're not expected to get a result back right away. Meaning that when you develop it, when you analyze this problem, you automatically are going to think about what happens if I no longer get a result back. Whereas if you're doing the same thinking with a synchronous communication, your mindset is not in that because you're expecting when you're thinking, you're expecting I'm getting a result back. So you're less likely to see the error conditions. So it says here you make your error conditions very visible. So as we now talking about 20 minutes about APIs, about style communication, asynchronous. So I talked about the introduction of a broker. I talked about messages, but I haven't really talked about events yet. So up until now, we looked at what the event-driven what the promises are. We looked at what the challenges are of APIs. We try to place it and put up some remedies for those problems, but we haven't talked about events yet. So the question bears, what are these events? And so events are really a special type of message. The message being the general term that says, I want to exchange information between two parties. And so when you look at that, this is the general term, but in those messages you can make a difference between the specific type of messages which we call events. And what makes them so different or what makes them so special is that these events, they either convey state, they say, this is what the order looks like, or they say that something in your system has happened. Guys, I've validated your customer. I've created a new customer. I've created an order. So this is basically the specific type of message that it represents. Now, if you look at those special types of messages, these events, now you can look at when are they used, when we are typically using these types of messages, events in our system. And the two most relevant use cases that you will find in your systems is the problem or the use case where you want to do data replication. So you have two systems, and I want one system is, let's say, the master of certain customer data, but I want to be sure that the data also is available in another system. And so what we do there is we can do this integration or this synchronization. We can do that with events because, like I said, events they can they can transmit the state, and we commit these states these events that we process. The other thing is with business automation or workflow automation. What we see there is that you have a workflow where different systems need to work together in order to complete a certain process or a certain workflow, and in order to signal between the different components that something has happened and someone else should perhaps pick up the ball and continue with the process, you can use events. I verified the customer. Okay, now that your verification of a customer is done, perhaps now we can, ask for authorization, something like that. So these are the most relevant use cases where those events are used. Now, let's come back and see that, okay, if you look at these use cases, how can they alleviate certain problems that we have? So this is an example typically of an API chaining that we have. A client wants to create an order. And so it does an API call to the order system. It says, give an order, but in order to create the order, you also are dependent on the customer system. So you call to the customer system, I don't know, to check what type of customer it is, and so we do the call there. So here we see two of our main problems, the chaining, if the customer system goes down, what happens, I don't know. But also the latency, we do an extra call. So one way of solving this problem is to ensure that the order system has the data of the customers locally available. So that when the client does the API call, it can complete it because it doesn't rely on the customer data because it has the customer data locally available. And how can it be that order system has the customer data locally available? Because we introduce events. What happens here is that the customer system, whenever a customer is updated or created, what happens? It will send out an event. Customer update has happened, or customer creation has happened. The order system listens to it and updates its cache, if you want, and it can complete its functionality without being reliable to the customer system. So this is one way. The other one, the other use case that I mentioned is the process automation. So to give you an example, let's have an example of a simple system here, where you have the order, and you have an order subsystem, you have a customer system or customer component, a payment component, and a warehouse component. And basically, what the order component can do, it can create a pending order, confirm orders, and so on. The customer component is there to verify the customer. In the warehouse, we can reserve stock, release stock, confirm the reservation, and basically, and then we have the payment system there. And so these are the different components in your architecture, and you want to be able to complete an order creation. So basically, what you have here, you have a workflow where what happens is the order system. You create an order or create a pending order, and it will create an event that says, "Okay, I created the order." Now, what happens then is the customer system is listening for that event. It will see, is there an order system? Yeah, okay, there is one order created. And it will then trigger its functionality. It says, okay, now I need to verify the customer linked to that order. Once that verification is done, so it posts an event that says, we have successful verification. The warehouse system kicks in and it says, you know what, I'm going to reserve this stock. I'm going to put it aside so that we are certain that we can ship out this order. Okay, that is done, so it says successful reservation, and then the payment system listens to that one and says, okay, I have a successful reservation, now I'm going to ask to authorize the payment. The payment gets authorized, again, successful authorization, payment authorized, and now the order system says, okay, I'm listening to that and I'm going to confirm the order, so now the order is confirmed. This is the workflow. And we have automated it by the introduction of these events and the different systems listening to those events. They're not talking directly to each other, they're just listening to those events. But this is a happy flow. Yeah. What can happen is, it can be that, so what can happen is that the verification of the customer, that's not the happy flow, and we know in the unhappy flow also with the presentation. But the verification of the customer is unsuccessful. Then again, what we need to do, the order system must listen to the event and cancel the order. Not only can the verification fail, but also the reservation can fail. Again, the order system must listen to the event and then listen to that and says, oh, the reservation failed, I must cancel the order. And again, the payment also can fail, so the warehouse system needs to listen to the authorization of the payment failed. Oh, I need to release the stock because the payment failed. Upon releasing that stock, it says it was an unsuccessful reservation. Again, the other system listens for this unsuccessful reservation and will cancel the order. And also, what I want to mention is it's becoming rather complex. And so my point there is yeah, if you work with events, so be it for data replication, be it for process automation, you have to be aware that it will have a significant impact on your organization. Meaning, I made here an example of this workflow. Yeah, what is your business strategy? Is that the way that you really want to organize your workflow, your process? Is that the way that you want to do that? Also with these different events that you're listening to, yeah, these are the events, how we will be structured them. There needs to be a certain governance around these events. I talked about this broker platform, that intermediate platform that you have there in order to publish those events into your application landscape. Yeah, you have a platform that how will you set that up? Will that be one centralized platform? Will that be a distributed platform? How will you do that? So there are different things there that you need to consider when introducing this type of events-driven mechanism in your application and in your solution workspace. And it's important that you are aware of those, because it's not all good things that come with events. There's also a certain complexity with them, and you need to be able and you need to be aware that you need to attack these complexities. And that's good that there are experts in the field that can help you solve these types of questions. So, to traditional APIs, REST-based APIs, and then an event system where you have these events that allow you to allow you to signal certain things. What's the main difference with it? If you look at it from a core, what's the main difference between those two items? And if you look at a traditional API, what you see there is when you do an API call, what your client will do is it will trigger a certain functionality inside your component, your API provider. So you're doing a call, and what you are doing is you're asking your API provider or your component to do a certain functionality. And based on that, you get a result or response. That's what traditional APIs do, and what they do good. Whereas with events, it's different. In events, the component that is responsible for generating the event, its sole responsibility is saying, guys, this has happened, guys, this is the state of that particular object. And then its responsibility ends. It doesn't do anything. Somebody might pick it up, somebody might not pick it up. He doesn't care. Once the event is published, what now will happen is that event will now trigger functionalities outside the provider. Because somebody will be listening to that. You say, oh, an order has been created, and somebody will now be listening to that and will in turn trigger functionality in itself. So you see that the functionality shifts. It's no longer the component. The functionality is with the others, and that's a big difference when looking at those items. So now that we looked at it, now let's see what problems did we solve. So first of all, let's look at the reliability. Here, what we can see is that, in a sense, we didn't completely eliminate the reliability problem, but we made it less urgent or less extreme, something like that. So take the example of this of the workflow where we have the order processing. That if the customer component went down, that verified the customer, I can still receive orders. They will be queued up. These events will be queued up, but I can still receive orders. Whereas in a traditional system, if you would have asynchronous communication there, if the customer system went down, I would no longer be able to receive my orders because I couldn't terminate my API call. If you look also at performance, also there, as we saw with these eventing systems, you can efficiently introduce a data replication mechanism, which allows you to ensure that data is locally available there where you need it. And so you eliminate the overhead of doing an extra call. Also, third point, push versus pull. These eventing systems, what they will do is they will notify you when a certain event has occurred. So basically, whereas previously you had to pull, getting are orders being made, the customer system, is there a new order so I can do the verification, so you will be pulling. With an event-driven system that is turned around in a push system. Once you put that event on this broker infrastructure, it will automatically send a notification to that customer system and says, there's an event for you, you can start processing. So it's a more efficient use of your resources that you can have there. Also, if you look at the high volume, if you look at also these messaging systems, the broker systems there, they are capable of handling millions of records. Some of those systems, of those messaging systems, were made just to handle the huge volume of data that AOT systems, for instance, generate. They are able to handle that huge volume of data because you store them on your queue or on your messaging infrastructure, and once they're there, they're kept, and you can process them one by one. It's made for that. Whereas in traditional APIs, it was not really made for that. And finally, if you look at the visibility, here also that one doesn't go away completely, but also you make it less burst. And so it's again, I'll take the example of that workflow system where the different systems talk to each other. They don't need to know each other. They just need to know which event are there. They need to have access to the broker infrastructure. And once they have that, they don't need to know if there is a customer system or a warehouse system. They just need to know if the event is there. And for them, it's irrelevant who creates that event. So it goes away from getting to know each of the actors in your system to the central point if you choose to implement it where you can get those events. If you now look at where you can find traditionally or now in the real life where you can find solutions that are taking advantage of that eventing mechanism. Where you can see it is we see it in microservice solutions. In microservice solutions, you have different components working together to bring you a certain business functionality. So there you can see that they use both types of use cases. They use it to do the data replication because it alleviates the weakest link problem, but also to automate your certain workflows. Also in real-time monitoring, what you see there, the real-time monitoring solution that you have there, you have that the data transmission, where what you typically do is channeling the data from your operational system into your monitoring solution that you have there. So you have that, but you also have the alert, the events that say that something has happened, and in the monitoring system, that's typically the alerts. Server went down, or disk from outer space. These are events that you see. These are the events that are triggered, and that in turn in your monitoring solution will trigger an alert so that you know that you need to do something. But not only in these things, you also see it in more traditional distributed systems that I used to program. It wasn't microservices, but it's more cross-grained services where you needed to do process automation, but also data integrations, where you see these use cases come back. And finally, yeah, like I mentioned in the IoTs, where you have a lot of data events being generated and need to be processed, and where you introduce this kind of solutions. So this is where you typically find these types of use cases where they use these event solutions to alleviate the problems that they tackle in designing those systems. So a lot about the meaning, about how you can, why events were introduced, what was the purpose, what were the problems, and then the purpose of the challenges that traditional APIs have, and how these events we try to solve or circumvent certain of those problems. But now, how is it in the real world? Are our IT systems ready to embrace this way of working? And to do that, what I did is I looked at the solutions that we have for traditional APIs. So if you look at the API management tooling, what you have there, typically you have a gateway that allows you to expose your APIs and does and the certain things there, and then again. The other aspect that you have is the developer portal that allows you to publish the information about your API so that others can really use it. And then, of course, you have all the standards that accompany those things in order to do the documentation, the open API spec or the Swagger that we have there. And then also very important is the developer community, how well are developers familiarized with APIs? And I try to look into that as well from a point of view when you look at it from the event point of view. So, if you look at the gateways, I've talked a lot of the brokers and basically these brokers. You can kind of compare that with your API gateway. So these are really the backbone of your solution, where your events get published, and also make sure that certain the other components get notified when there are new events. And what we see there is, they are really very mature. Messaging has been around a couple of years. If you look at Kafka, it's 2011, and that's one of the most recent ones. Q 2007, IBM messaging Q 93. So this is really very mature, the technology that you have there. And also, what's also very, I think, very important is if you look at the cloud solutions, all major cloud platforms support support the development of queues. You have a queuing infrastructure or messaging infrastructure there in the cloud, which really allows you to take advantage of those. If you then look at developer portals, I think if you ask about how content, I don't know if that's the right English word, but how content you are with your developer portal, it's kind of a mixed result. So some are very happy with what they have. Others say that's a little bit of lacking of functionality there. So even with traditional APIs, it's not a success story, I would say. But what we see as well is that vendors are starting to also implement functionality that allows you to expose information about your events, so that you can publish them, so that you have some kind of a portal where you can visualize those events, so that others are aware of it and can subscribe to that. And that brings us also to the third point, that is the documentation standards. APIs, I think that's one of the big advantages there. We have the Swagger and the Open API spec, which allows us really to describe it very well, the functionality there. But also there, we see that there are standards emerging and even being used. We have the Async API specification, but also the cloud events, which are standards that allow you really to define and describe those events so that they can be used by others. And also, certain vendors already implement those specifications so that you can really use them in their tool it's still emerging there, but you have there certain vendors like API, API Connect and source that implement this. So from that point of view, it's really very well covered. And also, if you look at the developer community, how well aware are the developers with it? Like I said, eventing is built upon your messaging infrastructure, and messaging infrastructure has been around for years. So your developers are kind of known with those paradigms and with those interfaces. And what you see also is that all the major brokers have really SDKs that allow you to easily integrate them. If you want to do it in your .NET or in your Java or whatever language that you want, you have really SDKs that allow you to easily integrate with those brokers. What you do need to be aware of is that it's a little bit more complex than communicating through HTTP. So what we see there, you have more complex paradigms. A lot of it is hidden from you to the SDKs, and be aware that I said it's top of mind. With this event, it's top of mind. What in the failure case? Because what if the response never comes back? That is top of mind, but even though you still need to make sure the developer cater for it, that you really have, take the example of the happy flow with the order, you also have to implement that non-happy flow, of course. And everybody is aware of it, but sometimes they tend to forget. So also from that point of view, it looks kind of good. So brings us to my last topic, the answer. Your next API, will it be event-driven? And I think the answer to that is yes, it can be or it could be. And why is it yes? Because see that your system will benefit from the asynchronous communication style that events will bring. Also, you have seen that really the technology, the infrastructure that you need, it's ready. So it's not that it's cutting edge technology, no, it's something that has been around for years now. And finally, that's also something that you have to determine is you are aware that you have the right expertise in your team to introduce this new state of complexity. But as I said, I'm a consultant. And with the consultants, there's always a but. So here's the but. You also know that it's not the golden bullet or the silver bullet for your solution. There is still merit, and there will always still be merit for a traditional APIs for the sync communication. And also, we have seen we have events. Events are a specific way of doing async communication, with data application, process automation. But there are tons of other ways to circumvent certain problems with async communication. Not everything is event-driven. You can solve a lot of your problems just adopting an asynchronous communication style. And so you have to make a distinction, what are you implementing in order to come to a good solution. And then the third one that I want to emphasize is it's not always easy to make this distinction is what type of communication style should I do, what type of integration style should I do. So really trust on your expertise in your team, your integration team, to come up with the right style that is good for your solution. So, to stay in theme with today, I put it a little bit different. Yoda, event-driven, your next API will be.
Any questions? Thank you. Good afternoon. Yes. but I didn't understand when you explained the differences between APIs and EDA. My question is, what role does API play in an EDA environment? I see that they can be used to define the interface for Async APIs.
It's really how do you define the term API. So what you will see here, because if you look at a traditional way, the REST API, what you have there is that's a way of defining that specific interface. Now, if you look at if you would if you would put the term API on these events, your API is the description of your event that you have. So we had just recently we had a big discussion internally, like should we call an event an API or not, because it's kind of different or not. But what you see in the market is that the term API is really a container term. And so what you will see when they talk, they don't make a distinction between REST APIs or not, that if you look at it, an API, you have two styles of it, one being the REST-based API, which you would describe with your Swagger file, and then you have, you call it event API, where you use your cloud events to describe that type of events that you have in your organization. And so this is what you then call your event API. It's a description of your events that you have in your organization where others can subscribe upon. Does that answer your question?
It does. Thank you for clarifying that there are public REST APIs. They can talk to microservices or to event-driven architectures, which can be documented using the event APIs, the Async APIs.
And like you said, that it's also with an external party. You can also transmit with API with events, so you can choose to expose it as an API, but you can directly expose your events there as well.
Thank you. Another question?
All right, then thank you very much, Joost. We will just have a 5-minute break to set up the next session.